Indiana Jones is searching for the lost Ark, which is hidden in the Well of Souls. Unfortunately, the Well of Souls is also hidden and can only be found by placing the Staff of Ra in the secret map room at dawn and using the rising sun to pinpoint its exact location. To make matters worse, he only has the headpiece of the Staff of Ra and not the staff itself. He has no idea how tall the staff should be, and without this critical piece of information, he will be unable to locate the lost Ark. Luckily, the ancient Egyptians were adept mathematicians and left behind this clue. Indy was glad that he paid attention in geometry class and that he knew his trigonometry. So, what is the correct height of the Staff of Ra, and how did Indiana Jones figure it out? Let's take a closer look at the ancient clue and put our math skills to work. Indiana immediately recognized that he did not have enough information. He needed to know at least one more angle or one more side length in order to solve the diagram. After a careful study, he realized the floor of the map room was not level. He measured the slope of the floor and then drew this figure. Jones knew he was on the right track. He had just a few more steps to complete before he could begin solving the problem. First, he realized the interior angle B is equal to 16 degrees, since vertical angles are always congruent. Next, Indy calculated that a vertical stick in the ground will intercept a level floor at precisely 90 degrees. Since the slope of the floor was 5 degrees, and he knew that complementary angles always add up to 90 degrees, he calculated the angle between the staff and the sloped floor to be 85 degrees. Lastly, Indiana Jones recognized this ancient Egyptian symbol of measure. The cubit, which was the ancient Egyptian unit length measurement, was based on the length of an adult forearm and is equal to 18 modern-day inches. Now he finally had what he needed. Let's get to work. We know that in triangle ABC, the measure of angle A is 85 degrees, the measure of angle B is 16 degrees, and the side length A is equal to 17.5 cubits. We must utilize two strategies to solve this problem. First, we will subtract the two known angles from 180 degrees to find angle C. Then we will use the law of sines to calculate the two missing side lengths of triangle ABC. Before we go ahead and solve this, let's take a stab at estimating the correct height of the Staff of Ra and compare it to our final answer at the end. This is helpful to ensure our answer is reasonable and correct. Imagine a pizza. One slice of this pizza is equivalent to triangle ABC. The radius of our pizza is 17.5 cubits, and the angle of each slice is 16 degrees. A pizza is really just a circle measuring 360 degrees. A 360-degree pie cut into 16-degree slices would yield 22.5 pieces. Now let's draw the formula for the circumference of a circle and apply it to our situation. The formula is 2 pi r. When we plug in the numbers, we get 2 times 3.14 times 17.5 cubits, which gives us 109.9 cubits. This is the circumference of the entire pizza. Now let's cut the 109.9 cubits into 22.5 slices. 109.9 divided by 22.5 is equal to 4.9 cubits. This means that each 16-degree slice of pizza is 4.9 cubits wide, and therefore is our estimate for the height of the staff. Now to solve this problem and find the lost arc. First, let's find the measure of missing angle C. Remember, since we already know two of the angle measurements of our triangle, and we also know that interior angles of every triangle always add up to 180 degrees, we can subtract the sum of the two known angles to find the remaining missing angle. The measure of angle C is equal to 180 minus the measure of angle A minus the measure of angle B, which means that 180 degrees minus 85 degrees minus 16 degrees equals 79 degrees, which is the measure of angle C. Now let's calculate the missing side lengths. Since we now know all three angles of triangle ABC, the best method to calculate the missing side lengths is by using the law of sines, which states that the ratio of the length of a side of a triangle to the sine of the angle opposite that side is the same for all sides and angles in a given triangle. This is how we can apply it to our problem. The law of sines is the side A over the sine of angle A is equal to side B over the sine of angle B is equal to side C over the sine of angle C. When we plug in our numbers, we get B is equal to 17.5 times the sine of 16 degrees divided by the sine of 85 degrees is approximately equal to 4.842 cubits. Next, let's find the length of side C. C is equal to 17.5 times the sine of 79 degrees divided by the sine of 85 degrees, which is approximately equal to 17.244 cubits. And last, why don't we convert cubits to inches in order to make the solution more meaningful? If you recall, 1 cubit is equal to 18 inches. 4.842 cubits times 18 equals 87.156 inches. Therefore, the correct height of the staff of Ra is 4.842 cubits, or 87.156 inches, which is also equal to 7.263 feet. Let's compare that to our estimate of 4.9 cubits. That is pretty close and should give Indiana Jones confidence that he is going to find the lost ark very soon.